We're on to the second lesson for Chapter 15. This is permutations and repeated use of the same object. So this is with repetition. We're at 15.2a. If you've missed the 4 previous videos for this chapter, you might become lost or confused, and you can click the description to watch those first. For an arrangement of objects to be a permutation, we can't repeat any of the objects, but in some situations, it's possible to use an object more than once. Doesn't that sound confusing? So we have a theorem for you. The number of orderings of n objects taken r at a time with repetition is n to the r. A, B, C, D. We have 4 letters. How many ordered ways can we write 5 letters if we allow the repeated use of the same letter? So we only have 4 letters, but we want to have 5 letters in our set. We can choose the first letter in 4 ways. We can choose the second letter in 4 ways. So we have 4 to the 5th power. We have 1,024 orderings. A standard deck of cards has 52 different cards. How many 3-card ordered arrangements can be made by selecting the 3 cards without replacement? So this is what we did in our previous video. This is without replacement. This is the number of permutations of 52 objects taken 3 at a time. So we have 52p3. That means we have 52 factorial over 52 minus 3 factorial from that theorem from that video. That means we have 52 factorial over 49 factorial, and we can expand this and write it with a factor of 49 factorial, then cancel out the common factorials, can't we? That leaves us with 52 times 51 times 50, which is 132,600. Now that's without replacement. If we want to do it with replacement, this is the number of arrangements of 52 objects taken 3 at a time with repetition. So we have 52 to the 3rd power. We have 52 times 52 times 52. That gives us 140,608. If we select 52 cards, 1 at a time, from a deck of 52, replacing the card after each time we choose, how many possibilities are there for the 52nd card? So think, we put each selection back into the deck, making the next selection no different from the previous one. 52 possibilities for the 52nd card. We're putting each one back, so it's almost like we're starting over, isn't it? What if we select 52 cards 1 at a time from a deck of 52 without replacing each card into the deck? How many possibilities are there for the 52nd card? Well, think. Each time we take a card, the deck has 1 less. By the time we go to select the 52nd card, there's only going to be 1 card left, so there's 1 possibility for that 52nd card. Bob's forgotten Dave's phone number, but he remembers that each of the 7 digits is either a 5 or a 6. How many phone numbers are possible? So think, we have 2 digits, a 5 and a 6, and the phone number has 7 digits. So we're going to do 2 to the 7th power, which is 128. An ice cream shop has 31 different flavors of ice cream. How many 2-scoop ordered arrangements can be made by selecting 2 flavors from the 31? If we do it without replacement, we've got 31p2, which is 31 factorial over 31 minus 2 factorial, which gives us 31 factorial over 29 factorial. We can rewrite the numerator with a factor of 29 factorial and then cancel the common factorials. That's going to leave us with 31 times 30, which is 930. Now, if we do it with replacement, that's going to give us n to the r, which is 31 to the 2nd power, which is 31 times 31, which equals 961. See the difference? So our next lesson is permutations with identical objects. We're going to be doing more with replacement. That's 15.2b. If you made any sense out of this video, please hit the like button so I know. And I hope you're doing well. I'm really proud of you for watching math videos on YouTube. And I'll see you next time. Bye.